heating controls explained and weather comp. My name's Alan Hart, and in today's video got an amazing video for you today. I'm at the National Gas Centre for Excellence, and I'm with Michael, and Michael is an expert on renewable energy. And in today's video we're going to talk about controls, we're going to talk about weather compensation, and then in future videos we're going to do air source heat pumps, we're going to do ground source, we're going to do solar thermal, we're going to do solar PV, battery storage, etc. So this video is a little bit of the starting block, if you like, into moving over to sort of like renewable energy. So hopefully this video today will be very useful for you. If you do have any questions at all, please put them in comments below, and we'll try as best to tailor future videos to whatever will help you, to be honest. So yeah, without further ado, let's go over to Michael.
Thanks, Alan. We've been asked recently by a number of our students to explain to them what OpenTherm is and how controls work. OpenTherm is a protocol that was developed by Honeywell a long time ago, and basically the best way of describing OpenTherm is that it's a language that all boiler manufacturers can use to enable their boilers to speak to third-party controls and controls that of their own making to maximise efficiency. Historically, we've been used to on-off controls on heating systems, thermostats on the walls, that all they do is make and break circuits. So the problem with that is that you've got a customer who, for example, sets a room temperature setting of 20 degrees, and once the room gets to that set point, so the boiler fires up at its running rate, it'll get the radiators hot. The radiators will then get the room hot and transfer the heat to the room. Once the room gets to that set point of 20 degrees, for example, the thermostat will tell the boiler, right, it's hot enough, stop operating. The boiler will cut out, but the water that's just left that boiler and the water in the radiators is still hot and is still passing its energy into the room. So what that causes is we very regularly overshoot the room temperature, so it might get to 21, 22 degrees, maybe even worse, depending on the insulation of the property. And then we have the same problem again as the room temperature's coming down. So when the room temperature is coming back down, it will get to 20 degrees and then the heating will come on. But the boiler's then got to work to get the water in the heat exchanger hot and transfer it to the radiators, which has then got to start transferring it to the room again. So then we might get temperatures of 19, 18, even colder again, depending on the insulation levels of the property. So we call this cycling, and what it looks like is our room temperatures getting hot, room stat tells the boiler to switch off, room gets hotter, as the room starts getting cool, it tells the boiler to come on, boiler takes some time to react and get the radiators hot again, and we get this constant cycling curve. Now that's really inefficient because it means that you get customers who are hotter than they need to be, and then they have hot and cold flashes in the room, and it also isn't great for boilers. Cycling shortens boiler life expectancy. It's harder on the controls, on gas valves, on expansion vessels, etc. So it's not desirable. So we've also got on-off modulating controls, which again do something similar, but they are slightly more efficient. Low compensation, which is what you generally get with OpenTherm, is where our boiler and the control is constantly speaking to each other, and your control tells the boiler how hot the water leaving the boiler needs to be in order to get to the set point that we've got in the room. So if we turn our heating on at, say, 5 degrees in the room, but the room thermostat or the control is set to 20 degrees, it will say to the boiler, look, we've got a 15-degree delta T here. We need to get some heat into this room fast. So the boiler will light on its maximum rate or on a high rate, and it will start transferring its heat to the radiators quickly, which will start transferring the heat to the room. The control will constantly monitor this, And as we approach that set point of 20 degrees and the DT between the room and but in the room reduces, it will gradually tell the boiler to slow down and decrease its output so that it will maintain a constant 20 degree temperature if possible. Depending on a number of factors, it could be that we've got, you know, poor insulation, or it could be that your boiler's minimum modulation temperature, minimum modulation output is quite high. You may still get the boiler cutting out, however, it will come back in as quick, you know, it'll react more to the room temperature. So the idea is you might get either smaller cycles, or the boiler will run longer, more continuously on a lower rate, which is more desirable. It gives us better control over our room temperature, and also gives us less cycling and less issues with regards to boiler life expectancy and you know, demand on the components of the boiler, which again, much more energy efficient when we talk about, you know, savings and gas usage. Another type of compensation is weather compensation, which again I think is a fantastic way of controlling your heating. Now, weather comp is we use the outside temperature. So if we take, I've drawn a chart on the board. If we take a 10 kilowatt heat loss in a property, so we've got a property with a 10 kilowatt heat loss, just to keep the math simple, and we've got a design outside temperature of -4. So what we're saying is the temperature outside in that area is likely ever really to only get down to -4 for, you know, 1% of the year, whatever it may be. At -4, our heat loss is 10 kilowatts. So that boiler will have to give out 10 kilowatts of heat to maintain you know, the room set point that we've designed the system to. However, if, you know, the other 99% of the year we've got, you know, somewhere north of that, so anywhere from -3 up to 20 degrees, we don't want to use the same 10 kilowatts of output from the boiler. We want to reduce that so that the boiler doesn't work as hard when it doesn't have to. Now, it's really easy to understand that if you've got 20 degrees outside and 20 degrees set temperature inside, you don't need any heat from your heating, because the outside temperature is sufficient to heat your house without any input from wet central heating or any other form of heating. At 8 degrees outside temperature, your boiler only has to put 5 kilowatts of energy or 5 kilowatts of heat into that property. So this is where we can break this down. We can see, you know, at 16 degrees outside, we only need 1.7 kilowatts. At 12 degrees outside, we only need 3.3 kilowatts. At 4, 6.6, and at 0 degrees, it would be 8.3 kilowatts. So it's quite easy to see straight away that although we might have a 10 kilowatt heat loss in our property at, you know, worst case scenario, the vast majority of the year we don't need all of that heat out of our boiler. So weather comp's a really good way of the boiler being able to monitor how hard it needs to work to keep your property and your customers warm. So what I'd like to do is also talk about how you'd set the weather comp charts, because how weather comp works is it's got an external temperature sensor on the outside of the property, usually on a north facing wall, and that constantly monitors the temperature via an NTC stat. Now, depending on the resistance going through that stat, you know, which depends on the temperature outside, the boiler is able to ascertain what temperature it is and ultimately how hard it needs to work to keep that property warm. If you've got, you also have setback temperatures. So you might want, through the day, you know, at a various temperature outside, a certain degree of flow. So a certain temperature of flow coming from your heat generator or your boiler, air source unit, whatever it may be. Now, of a day, you'll want a different temperature than what you will at night when you're at work, or sorry, when you're asleep. when you're asleep, you might want a lower curve to be selected so that overnight it drops down a couple of degrees, 3 or 4 degrees maybe. Depending on your heat source, that, you know, really that, and also the insulation and thermal mass of your property, that's really what you want to be looking at. It's not this, you know, one solution doesn't fit every type of customer. For something like an air source unit, it is desirable to have a slightly lower setback temperature, again 3 or 4 degrees. If you've got a system where your customers at work for large portions of the day, you know, you may want to not look at weather comp. It might not be the best solution for your customer. It might, you know, something like an on-off control might be better. But again, it depends on the technology, the insulation of the property, the mass of the property, all sorts of different factors, and also the type of customer and how they live. Someone who's retired, for example, might want to spend more time at home through the day, and therefore weather comp will be perfect for them. If they've got an air source unit, or if their heat generator is a condensing boiler or something that's, you know, what we see is more energy efficient, you would use the weather comp settings with a setback, so that the boiler doesn't have to then work harder in the morning to get the room and the property back to a desirable temperature. And also the mass of the property, so the brickwork, the floors, they will also act as radiators, for lack of a better word, and they will store some of the heat and maintain it, so that the property, you know, the heat source doesn't have to work harder to get that temperature to property, that the property to temperature, sorry. If you've got a sort of more modern property, you know, with not cavity walls, stud walls and floors that don't have a lot to them in terms of mass, so they heat up quickly and they can lose heat quickly, then you would probably not look at maintaining a setback temperature, because ultimately the mass of the property is not going to retain any of the heat. There's no benefit to it. So there's multiple factors that you need to look at, and this is where engineering design perspective comes in. So let's look at some heat curves, and we'll talk about how we'd set them so that, you know, at our -4 outside, the boilers were sending out maybe 70 degree flow, 60 degree flow temperature out to the boiler, into the radiators, whereas at 8 degrees it might only be sending out something less. So let's have a look at a chart and see how we would set that on the control panel to the boiler. So when we talk about weather comp, what we will have to do as part of our commissioning process is tell the boiler what temperatures we want it to operate at, as per the design of the building or the property. So we'll generally design a property to a design outside temperature and a design inside temperature or room temperature. What we'll also need to factor in is what flow we're going to use. So we will have designed the emitters of the system and also designed the boiler to operate at a temperature at its maximum output. So we always want to try and maintain the return temperature at less than 54 degrees so that the boiler's condensing. I generally size my system so that I can operate the boiler at 60 degree flow and 40 degree return if achievable. However, we need to use this chart. This is off of Eastman V200. So this chart should allow us to enable ourselves to select the correct curve, and these are the curve numbers. So each curve, each line has a number associated with it, and you can input that and you can tell the boiler which line you want the boiler to follow. And then when the outside sensor is at a certain temperature, the boiler knows how cold it is outside, and it will adjust the flow temperature leaving the boiler to maintain a set temperature of 20, or 20 degrees is generally what we design heating systems to, roughly. So how would we do that? Now, if we have a design outside temperature of -4, like we've said, I know, using my systems, what the systems I design, worst case scenario, 60 degree flow. So therefore, at roughly -4, which is here, I want a 60 degree flow. So if I follow this line up all the way to 60 degree flow, I'm around about there. I would probably select curve number 1.6. So I would input that as part of my commissioning process, And that means that at -4 outside, my boiler would throw out a 60-degree flow. Now, just because it's kicking out 60-degree flow at -4, it also means that if it's 5 degrees outside, using curve 1.6, if it's 5 degrees, the boiler will only be trying to output roughly 47-degree flow, which means that if our DT is the same, maintained at 20 degrees, you'd have about 27-degree return, so you're well into that condensing mode. The other issue with this, which people may find if they start using weather comp, is that customers, this is relatively new technology to customers. So in the same way that we do have issues with heat pumps, customers generally might feel the radiators and say, well, hang on, my radiators are lukewarm or they're not that hot. I'm used to them being hot, especially if they've come from a traditional system where we've had high flow temperatures, on-off controls, where we overshoot and undershoot design temperatures. It's an education piece with your customer as part of, first of all, your design and your sale technique, and also when you're commissioning and you're handing the system over to the customer, you need to let them know this system isn't going to work the same way as your old system did. Eventually, you know, you're going to have a warmer day outside, your boiler's not going to have to work as hard, and as such, your radiators will not be as hot, but your room temperature will be the same as what it would have been anyway. And that's probably one of the biggest obstacles that we've got to face as an industry moving forward. It's an education piece, not only with engineers, but also with customers. But that's basically how you would select a heating curve, and that's how they work. You take your outside design temperature, you take your room temperature that you want to select, in most cases 20 degrees, 21 in some cases, and then you have your design flow temperature for your heating system. That's, you know, that again boils down to system design and how you've done it. You might not always get it right. You might select one curve, and then your customer might give you a call in a week and say, well, it's a little bit cold, can we make it a bit warmer? And you might decide that you want to move from 1.6 to 1.8 or 1.6 to 2. It's entirely down to you. It is relatively rare that you're going to nail it first time round. You probably want to feed that to your customer as well. You know, we might have to come back and just alter your heating curve to just ensure that you're as comfortable as possible and that your system is as efficient as possible whilst maintaining your comfort. So now we've discussed weather comp in a bit more detail, let's go back to some controls and see how we would wire OpenTherm in, if we're able to, on some controls. So when we are selecting the control that we want to use, we want to be selecting an OpenTherm compatible control for an OpenTherm compatible boiler. Now that might sound really easy. Is my boiler OpenTherm? Yeah. Is my control OpenTherm? Yeah. Therefore they should work together. However, this isn't always the case, as much as we'd like it to be. First of all, some manufacturers have their own version of OpenTherm, so the likes of Worcester and Valent use Bus and eBus. The likes of Wiesmann, Baxi, Ideal, Maine, they do tend to stick with OpenTherm, but even that can cause some issues. Ravenheat's another one they work with, and their boilers are OpenTherm compatible. However, they don't always work with some OpenTherm controls, so it's important that you are able to identify by either speaking to a manufacturer and also speaking to a controls manufacturer or seeing online if the controls and appliance is compatible with each other. There's just a note, there is a good website, somebody called Joe Alsop at theheatinghub.com. They have a really useful page online, and they break down really well what boilers are compatible with what controls, what third-party controls you can use, what controls made by the manufacturer can, their version of OpenTherm, if you like. So that's probably a good website for you to look at. That should give you the vast majority of the information that you're looking for. So I've selected a Nest, for example. So I quite like Nest. It's Google. You get what you expect from Google. A lot of people disagree and prefer Hive or something different, but I do like Nest as an engineer. So if we talk about a combi boiler, And we'll use a Wiesmann just because I know that Wiesmann and Nest work quite well together. On a Wiesmann, you'll have OpenTherm connections. Now they will be different connections to your thermostat connections. So if on your average combi boiler, for example, you'll have a live, neutral and earth, usually permanent supply, and then you'll have, well, we refer to them as T1 and T2, or live and switch live, whatever it may be, A and B. There's a multitude of different ways that it can be called. So that's what these two terminals are. Now these say OpenTherm, but imagine that they don't. Imagine they are the thermostat connections if you want 230 volt or low voltage, whatever it may be, or volt 3. Normally we would be taking these two wires to terminals 1 and 2 for a standard control, standard efficiency, and that's basically what our old controls, the on-off controls are. So wiring a control to 1 and 2 will probably give you, apart from unless the boiler's quite smart, it'll give you the same issue that we spoke about at the start, where you might overshoot your temperature and undershoot. The much more desirable way to utilise a Nest with a boiler that's OpenTherm compatible with Nest would be to wire the OpenTherm connections on the boiler to OT1 and OT2. And what that will mean is that the boiler will operate within the OpenTherm protocol. So it will, once the set point of the room's being approached, it will modulate the boiler down. The control will talk to the boiler and say, right, we're nearly there, stop working as hard, we're nearly at the finish line, at which point you can just sort of canter along and not put too much energy into the room that we don't need. So that's an example of how you would wire in OpenTherm. And again, this is the same thing applies to heat-only boilers, system boilers. It's irrelevant really, as long as your boiler is compatible with OpenTherm controls, or the control that we're talking about, and vice versa, the controls compatible with the boiler, then we can utilise this technology and have a much more efficient system. As always, thank you for watching. I hope you found this video informative and educational somewhat. If there's anything that you thought the video lacked, or you'd like any further information on, by all means leave a comment below, like and subscribe. It's always appreciated. And the goal for us is to be able to give you guys as much information that you want and that you find relevant to your everyday work life. So anything that you ask us for, we'll endeavour to get it done for you. But yeah, thank you very much. And if anyone wants to come and visit us at the National Gas Centre for Excellence and come and see what we're about, or book courses with us and give us the opportunity to show you what we're about, then that'd be greatly appreciated. Thanks everyone, have a great day.
Thank you very much for that, Michael. If you've got any questions, as I've said, as always, please put a comment below, and as always, if you could put a thumbs up, really appreciate that. As I say, we are going to do quite a lot of these videos now, all to do with renewable. So we're going to do air source, we're going to do ground source, we're going to do PV panels, we're going to do battery storage. We're going to do the full journey of renewable, or as much as we can. So if you do have any questions on any of that, then please put a comment below, and we'll try and do videos tailored to whatever people want, whatever questions you've got. But at my house now, I've got the PV panels. I'm getting the battery storage installed shortly as well. We're going to have an air source heat pump at my house. We're also going to have, this is going to be the centre of excellence for air source here. So we're going to have air source heat pumps here. So we're going to do training here on air source heat pumps. Solar thermal as well. We're going to do solar thermal training at some point as well. So yeah, exciting times. As I say, if you've got any questions, please put them in comments below, and thank you very much for watching.